It's that time of year again, sunscreen season. I'm Michelle of Lab Muffin Beauty Science. I'm a chemist and sunscreen nerd, and nothing makes me feel more like I am pushing a rock repeatedly up a mountain than sunscreen season. Every year, all the same myths about sunscreen go viral again. Sometimes someone invents some brand new ones too. So today I'm going to debunk a whole bunch of these in like a vent session. If you've been here for a while, this will be group therapy. So grab your drink of choice. I have some spicy water, grab a snack, let's get into it.
This is animal-based sunscreen, 100 million, billion, zillion times better than traditional sunscreens or other, quote, healthy sunscreens, which are full of seed oils and all kinds of carcinogenic garbage. In this video, I'm gonna show you how to make this. This is so healthy you could even eat it. Pretty good.
So this is Paul Saladino. He's a medical doctor who is or was a psychiatrist. He used to call himself Carnivore MD, but he's kind of gone off all meat diets. He's introduced like pineapples to his diet now, so he's really into animal-based instead. He usually talks about nutrition, but for whatever reason, a whole bunch of nutrition dudes have started talking about sunscreen, and it's all mostly been not great. So no surprise here, his skin advice is also not great. So let's check out his DIY sunscreen that also doubles up as a snack. I don't know if any of you pick sunscreen as your snack for this video. Well done.
This is all it takes to make your own animal-based sunscreen. So this is an improvised double boiler, just an inch of water in there that I'm gonna boil, 2 tablespoons of beeswax, ½ cup coconut oil, and ½ cup of tallow. Melt these, mix them together, and then I'm gonna add the zinc. Removed it from the heat, stir this for a couple minutes, let it cool. When it starts to get a little more mushy, use a hand mixture and whip air into it to give it more of a texture.
Okay, I really respect his use of a double boiler. Those are really good for melting things gently, but DIY sunscreens like this are just not a good idea. DIY sunscreens in general are just not great. And that's because effective sunscreen isn't just about the percentage of zinc oxide that you've put in there. Zinc oxide is a sunscreen ingredient, but it's not just quite this simple in a proper commercial sunscreen. It's not just the percentage, but also how that zinc oxide is distributed in the sunscreen and how that spreads on your skin. You might have the same weight of zinc oxide, the same percentage, but you can have it spread out into little particles versus one big lump, and that will be the same percentage. The spread out version is going to cover up more skin and block more UV than if it's all in one big clump. Smaller zinc oxide particles also absorb more UV and they reflect less visible light, so they work better as a sunscreen, plus they look less white. Most DIY recipes use uncoated non-nano zinc oxide, which is what he's using here, and that's probably because it seems more safe and natural, but the coating and the extra grinding, even though it feels unnatural, like that coating is often synthetic, it is done for a reason. It is more effort and more expensive, but it makes it work better as a sunscreen ingredient. Sunscreen companies aren't paying more for the fancy unnatural zinc oxide if it doesn't have benefits. That would be a really crappy business decision. That synthetic coating on the zinc oxide stops it from clumping up as much. Zinc oxide just loves clumping up, especially in oil. It is hydrophilic. This is like an oil base, which is what most DIY recipes use. So the zinc oxide particles want to touch as little oil as possible. They're going to want to touch more of the zinc, so it clumps up. You get chunks. So he's put this extra clumpy zinc oxide into a bunch of oils and he's mixing it up with a hand mixer. That hand mixer is not powerful enough to unclump zinc. It is clumped on a microscopic level. You need violence to undo that. In proper sunscreen production, they'll use industrial equipment, high-shear homogenizers, not like a piddly little hand mixer that would struggle with bread dough. But even if you have enough of the right type of zinc oxide and you mix it with industrial equipment that can make the zinc oxide spread out properly, sunscreen formulators still get really low SPF sometimes because the base isn't keeping that zinc oxide spread out when you're applying it on your skin or even just in the bottle. This is why sunscreen is considered one of the hardest products to formulate. There is so much optimizing and testing to try to get a zinc oxide sunscreen that achieves consistently good protection on skin. Some researchers actually tried making different homemade sunscreen recipes with up to 35% zinc oxide and they estimated the SPF. They all ended up as under SPF 6. You just don't know what sort of protection you're getting with a DIY sunscreen until it's too late, until you have to find out by getting burned or getting cancer, and it is probably going to be a low SPF most of the time unless you are extremely lucky.
Seed oils in your healthy sunscreen. Many of these healthy alternative sunscreens contain seed oils. Just like you don't want to eat seed oils, You do not want to put seed oils on your skin because that seed oil is then going to go into your skin, into your dermis and epidermis, and accumulate in your cell membranes there, making them fragile so that when they come in contact with the sun, they get damaged.
Okay, so I looked further into this. This is like Paul Saladino's seed oil theory of sunburn. I'm not really sure if he started it. He's explained it in a different video on YouTube, and I've seen a lot of people sort of reference this on social media. Basically, the idea is seed oils have linoleic acid or omega-6 that has a double bond in its structure which oxidizes more easily than saturated fatty acids. All of that is true. Where this theory starts to go pear-shaped is these seed oils then go to your cell membranes, they react in UV, your cell membranes burst, and then you get sunburnt. The problem is, this is not how sunburn happens. Sunburn starts when the DNA inside your skin cells absorb UV radiation. So I got this whiteboard and a bunch of whiteboard markers. I'm going to use them, but I haven't really worked out the setup. Right now it's in like a swivel chair. Stay tuned for my great setup at some point. Okay, so this is DNA. It's sort of like a ladder sort of structure, like a ladder spiral structure. And we've got base pairs in there, and some of these bases are thymine. That's what these two are. So when UV comes in and it hits two thymines that are next to each other, the double bond can absorb that and it undergoes what's called a 2+2 cycloaddition. So this double bond ends up there, this double bond ends up there, and you end up with a thymine dimer. Now your DNA is munted, technical term. If it's munted enough, the cell undergoes an honorable programmed death called apoptosis, which is like cellular seppuku, and it turns into a sunburn cell. And this is so it doesn't stay alive and turn into a cancerous cell, which then reproduces and turns into a tumor. Thank you, cell, for your service. A few cells don't do this, so they replicate and they spread the messages in this munted DNA, and that's how you get cancer. And this mechanism is really well established. There are tons of different types of evidence for this dating back to like the 1980s. There are even studies where people who are exposed to more sunlight pee out more of these thymine dimers. Now, this is what a cell looks like. That is a terrible diagram. Now, this is what a skin cell looks like. It's got the cell membrane on the outside and then the nucleus where the DNA is on the inside. If we have linoleic acid in the cell membrane, and then we have UV coming in and hitting the linoleic acid and having it react, that UV is getting converted into chemical energy in that reaction. The linoleic acid would be intercepting the UV before it hits the DNA in the nucleus. It would be preventing these thymine dimers from forming. Basically, the mechanism he's describing is showing linoleic acid acting as a cell-level sunscreen. Like, this is how sunscreens prevent sunburn and skin cancer. The sunscreen sits in between the sun and your DNA. This broad idea that seed oils are toxic, it is a really common trope in alternative nutrition. There are some really good debunks of this from a dietary point of view. I will link them in the description. But it is so bizarre to me that this has been imported into skincare, the idea that linoleic acid and omega-6 make skin fragile, because if you read the scientific literature, everything points towards linoleic acid being like one of the best fatty acids for your skin. There are some really cool studies showing that seed oils and linoleic acid are great for your skin barrier, that is the stratum corneum. Linoleic acid gets turned into specific ceramides that make your skin less dry and flaky. It sits in like this wiggly lipid part. This diagram is from my book, The Science of Beauty. We have less of these ceramides in our skin in winter, and there are a couple of really interesting studies that found that putting the seed oils on your skin meant that enzymes in your skin converted the oils into these ceramides. It makes your lipid barrier more robust and waterproof, and this is probably why rosehip oil is such a cult product. It's got lots of linoleic acid. There's also a bunch of studies showing that people with acne are deficient in linoleic acid. There's less of it in their sebum, which is their skin oil, compared to people without acne. There are studies showing that taking it in supplements or applying it decreased acne and inflammation, which is a big contributor to acne. So it's just really funny to me that for so many years, people who are into skincare, into the science of skincare, they've been purposely looking for linoleic acid products because of all this research and having great luck with it. And then suddenly these guys who honestly probably haven't thought about skincare in their lives, and I mean, they don't look like they really care about skincare. They're just coming in and telling us that we've just been wrong the whole time. I don't know, maybe one day I will do a whole separate deep dive into seed oils and skin.
Making your own sunscreen or looking for a tallow-based sunscreen is probably the best option out there, because a lot of these healthy alternative sunscreens are actually not that great. I would never put them on my body, and I would never recommend them to you guys to put them on your skin when you're in the sun for protection.
It's also just so silly to me that he is recommending his untested DIY tallow sunscreen when all of these sunscreens that he's bashing, they've all been scientifically tested to protect actual humans from sunburn, even though they have seed oils and all these terrible things in them. All of these commercial products that have an SPF number get that number through direct testing. It's currently done using the ISO 24444 method. The sunscreen is put on actual human volunteers and then UV light gets shone on it. That SPF number is how many times more UV the skin can handle before going pink with the sunscreen on. If these sunscreens with seed oils in them actually made your skin more prone to sunburn, they would have SPF numbers below 1. I mean, they would probably just never get released. His tallow sunscreen doesn't have the standardized empirical testing to back it up. If there is a tallow-based sunscreen out there that's been properly SPF tested and manufactured in a consistent way, then that is great. If you like it, you can use it. But it's just so ironic that I don't think he realizes he is literally showing us the empirical data, the experimental results for these sunscreens working in his video.
Ladies, I do have sad news for you. SPF number is not how strong SPF is. It's a time, if you get burn your skin, let's say in 20 minutes, right, sitting in the direct sun like I am right now. Nobody gets burned in 20 minutes actually, but let's say you get burned in 20 minutes. And 25 times 20, it is 8.3 hours. This is why SPF 25 is enough. I don't know if that makes sense, but you do not need SPF 50 or 100. That is not a strength.
First off, if you are in Australia, you can definitely get burnt in 20 minutes. I see this idea a lot from estheticians. She calls herself a holistic esthetician. I feel like when people say they're holistic, what it really means is that they don't really have an information filter. They don't have critical thinking. They just take in all of the information holistically. There's another really big esthetician who posted this recently, and I think this myth comes from how SPF is tested. The equation that they use to calculate SPF does actually mention time, but the only reason this works is because in SPF testing, they use a lamp that puts out consistent UV. So the strength of the sunscreen, like how many UV light particles are stopped from going into the skin, that is directly linked to time. So when you put it into the equation, you get the same number. But in real life, you don't have consistent UV. It changes all the time. Like if the sun is coming in through here and hitting my skin here, if I turn my face slightly, then that's going to get a whole bunch less UV because the same amount of UV is now spread out over a diagonal. This esthetician defended her post by saying these examples are true to how lab measurements are done, but the UV lamp they use is way stronger than the sun, so the volunteers don't ever lie under the lamp for 1500 minutes, which is 25 hours. If people had to lie still for these tests, you would just have no volunteers coming for these tests. You can just crank up the lamp and actually get people. So that's the time part of the myth. Now, the wider issue, do you actually benefit from higher SPFs? Now, if you apply the right amount of SPF 25 perfectly evenly at 2 milligrams per square centimeter, and it stays like that the whole time, then only 1/25 or 4% of the burning SPF will get through. It will take 25 times as long to burn, but this is achievable in a lab but not in real life, and this is the same as the myth that SPF 50 is only 1% better than SPF 30. In the test, they only need to apply sunscreen to a really small patch, and the reason they need to do all this stuff is to get consistent numbers so that you get consistent results to compare sunscreens with. But this isn't really true to how we use sunscreen in real life. There are studies showing that people apply usually less than half of the right amount. If you apply half of the sunscreen, then you get approximately half of the SPF, so twice as much of that burning UV gets through. So the reason we get benefits from higher SPF is because it makes up for under-application. Even if you measure out the perfect amount, you're probably not going to apply it perfectly evenly. You'll probably have some bits where you'll have a bit less than you should, and some bits where you have more than you should. And it won't stay like that over time. Some might get rubbed off, or it might start cracking and getting gaps if you start sweating or if you have oil coming out. There are studies that have found that people get burned less with SPF 100 than SPF 50 because of these real-life conditions. Now, the traditional recommendation is to wear SPF 30 or higher, and that was mostly because higher SPFs used to be more expensive and also a lot more unpleasant to use. But these days, that's not really true anymore, so I think in general it's just if you have two sunscreens that you like equally, the one with higher SPF is going to give you more protection.
Why is nobody talking about this? all these sunscreens are not doing the job they're designed to do. They're meant to protect you from the sun, right? But why then does this chart show that since 1975, the increase in skin cancer rates is going up and up and up the more sunscreen we use? Makes no sense, right? It's not having good health outcomes for our populations.
I've seen this one a lot, and I mean, it's not a bad question, but some people also go further and they say sunscreen actually causes skin cancer. So let's start off with that first. The obvious thing here, correlation isn't causation. This graph isn't even showing a correlation. There is no line for sunscreen here, just a general trend of increasing melanoma incidence in the US. A lot of other things have also increased over that time. We could argue that increasing chocolate consumption is causing skin cancer, more electricity use, more cars, more TikToks about sunscreen being dangerous. This is one of my favorite websites, Spurious Correlations. You can upload data and see what correlations you get. For US melanoma rates, the correlation with babies called Mariam is really good. Sunscreen only really started being in widespread use in the 1970s, so this is really a continuation of like an existing trend. But a more important point, this overall increasing trend isn't happening everywhere. It isn't happening in Australia, which is probably the country with the strongest sunscreen culture. Melanoma in young people has actually decreased, so in people aged 15 to 24, it's actually decreased to about half of what it was in the 1980s. And research shows that this is because of our sun smart education initiatives. This isn't just about sunscreen, but also other sun protection strategies. So you might have heard of slip, slop, slap, seek, slide. And this seems to be the biggest reason why the trend is different for Australia. Other countries haven't had a really coordinated public health approach to sun protection. Just knowing that sunscreen will reduce skin cancer doesn't mean that people are going to apply it properly and do other sun smart things. A lot of what actually guides behaviour is values and convenience and habit. I don't think a lot of non-Australians really understand how pervasive all this sun education was. I lived through that, man. I think everyone who grew up in Australia remembers no hat, no play. Basically, this is if you didn't bring your hat to school, you had to sit on a bench and just watch everyone else play at lunchtime. Eventually, it turned into no hat play in the shade, possibly because all the teachers realized that this was really mean to these like tiny little kids. And these were like hectic hats. They looked like this. They had this full flap thing going on. And if you tried to be cool and like tuck it up into the cap, then the teacher would be like, Tim, put down your flap. A lot of sun protection was like cool, like everyone wanted the coolest rashi, everyone wanted to have zinc sticks that matched their school house colors. They really drilled the Swiss cheese model of sun protection into us. This is another diagram from my book. I should really talk a bit more about this. This is my book, The Science of Beauty. I wrote it last year. It was a massive project. It answers a whole bunch of questions on topics like hair care, skincare, nail care, makeup, and just beauty products in general. There are a whole bunch of diagrams in it. I learned a lot writing it. Lots of the videos that I have planned are based on chapters inside this, so it's sort of like a preview of my next few years of videos. It's out for pre-order now. The link is in the description, or you can use the QR code. Back to the cheerful topic of skin cancer. So this increasing trend is also influenced by a whole bunch of other variables that aren't controlled. We do also have evidence collected under control conditions that show that sunscreen prevents skin cancer. For example, we have this clinical trial called the NAMBA trial, where there are people in the same location, they're of similar ages, they have similar skin color. The only big difference between the two groups is sunscreen use. Half the people wore sunscreen every day consistently, the other half only wore sunscreen when they wanted to, so discretionary sunscreen use. And the results are pretty convincing. Melanoma incidence halved, squamous cell carcinomas reduced by 40%, and the people who used sunscreen daily were 24% less likely to show signs of aging. Here's another experiment. Different amounts of sunscreen were applied before blasting the skin with a lamp that gives the same sort of light as the sun. Then they looked for thymine dimers, which was that munted DNA. That is the first step towards skin cancer. And a taller bar means more of that munted DNA. The tallest bar was for no sunscreen. The more sunscreen there was, the less messed up the DNA got. So why is the cancer increasing? Basically, there are more things that are pushing the cancer rate up that is overwhelming how much the sunscreen can push the rate down. The main explanations, first off, we are living longer, so cells have more opportunity to mutate. The average age that people get diagnosed with melanoma is 65. People used to die of other stuff before they got counted as a skin cancer case. We've also gotten a lot better at picking up skin cancer early, we have better detection methods, and we've got greater awareness of looking out for weird looking moles. We also have really different lifestyle habits now. People are going on beach holidays a lot more, so a lot of people are being exposed to basically 2 summers a year. It's a lot easier now for people who don't live near a beach to go to the beach. There is also this greater desire for tanning. The US FDA started regulating sunscreen around the same time that UV tanning beds appeared. Whew, that was a long explanation for a very short video. This whole series of videos is basically just an exercise in Brandolini's law. That is, it takes an order of magnitude more effort to debunk the BS than it took to produce it. It's also called the bullshit asymmetry principle. Oh, I probably needed something stronger than spicy water.
This video will be controversial. As a dermatologist, I don't wear chemical-based sunscreens, only mineral-based. I recommend the same to my patients, especially my pregnant patients. Here's why.
I've seen a lot of dermatologists say things like this. I think it really does highlight that dermatologists don't have that much of a base level of education on toxicology and cosmetics and ingredient safety as some people assume they do. I also talked a bit about this recently in my video on sunscreen contamination, which was a hot topic in sunscreens a while back, so check that out too. Now, this isn't all dermatologists. Some dermatologists have educated themselves on it, but other dermatologists seem to not realize toxicologists exist, and they assume that dermatologists are the ultimate authority on toxicology, which is not the case and has led to a whole bunch of myths.
A lot of the chemical sunscreens that we apply are absorbed into the bloodstream at concentrations higher than we once thought. Now, to be fair, these studies apply the sunscreens quite a bit. However, if you're applying sunscreen even to a small area every single day over years, although the concentration in your body may not reach the same as in these studies, your cumulative exposure is still pretty high. And no one can say with 100% certainty the effect of this cumulative exposure over 10, 20, 50 years.
So this 2020 study that he's showing is by the FDA. It is what led to a whole bunch of headlines saying that we've just discovered sunscreen can be absorbed into the blood, please panic now. But the background behind these studies is really important. Before them, FDA regulations basically assumed that sunscreen wasn't absorbed into the blood at higher than half a nanogram per mil. And this is the concentration where the FDA assumes that any ingredient is safe by default. This all goes back to the dose makes the poison. Basically, for a substance to have an effect inside your body, positive or negative, it has to interact with something inside your body and change it. The reason this is important, it's a bit like throwing coins into cups, so assume that you need a certain number of coins in the cups to have an effect. The more coins you have, the higher the chance is that you reach that threshold, but if we have only a few cups spaced over a football field and you only have 2 coins, then it is just so ridiculously small, the chance of you reaching that threshold, that you just don't have to worry about it. So that is essentially half a nanogram per mil for this. It is too low for these molecules to hit enough targets, so safe by default. So this study didn't show that chemical sunscreens were unsafe. It just meant that from a regulatory point of view, they couldn't be assumed to be safe by default. So this might sound scary, except that the significance of this study was mostly from a regulatory point of view for the US. The US isn't the only country that uses sunscreens. Other regions like the EU have been assessing sunscreen safety, assuming that it absorbs into blood for decades. I've gone through the EU's safety assessments and details in this video, which I got checked by some toxicologists. So he says that applying sunscreen every day for years could change the safety, and yes, that is true, but that is taken into account in the safety assessments. Also, the way he's said cumulative exposure does sound kind of scary, like the sunscreen is just building up and up and up inside your body, but that's not the case. First off, most of the sunscreen stays on top of your skin and your skin sheds, so your sunscreen gets shed with it. The very, very low percentage, like a fraction of a percent of sunscreen that gets into your blood, will also mostly get metabolized. You might have seen studies where they detected sunscreen ingredients in pee. That is actually your body getting rid of it.
So what's the issue and why pregnant women? Some of these chemicals are known hormone disruptors or suspected of being hormone disruptors. So which mineral sunscreen do I recommend? I've previously done a video comparing a cheap mineral sunscreen to an expensive one. Worth a watch.
So this isn't true with sunscreens in humans according to the scientific definition of an endocrine disruptor. I think a lot of people think that anything that changes your hormone levels is an endocrine disruptor, but if that was the case, then almost everything would be an endocrine disruptor, like food, light, thinking too much, stress. All of that would be endocrine disruptors. So the definition of an endocrine disruptor, it needs to alter the function of your endocrine system and have a negative health effect to count. So there have been effects in animal studies with mostly unrealistic amounts, and there have been some conflicting biomarker changes in human studies. So all of this is why the EU's expert panel has been re-examining sunscreens as potential endocrine disruptors. I've gone through how these are done before in that video, and so far they've rechecked 5 chemical sunscreens, starting from the most sus ones, and there wasn't enough evidence to say that any of the ones he's listed were endocrine disruptors. Now, the allowed amounts of some of these have decreased in the EU, but there are a few important notes that really puts that into context. First off, they take application amount into account, so for homosalate, it's now limited to 0.5% in body sunscreens. And this is based on what they expect would be safe for someone to use all over their body every single day, but for face sunscreen, the allowed percentage is 7.34%. These allowed percentages are also just a tiny fraction, usually 1/100th, of an amount that still shouldn't give any tiny potentially harmful effect. What they use is usually the no observed adverse effect level. So in that context, the EU allowing, say, 2.2% oxybenzone versus the US allowing 6% is really not a huge difference. It just means that the EU thought that up to 220% was still safe, while the US thought that up to 600% was still safe. Now, there actually is one chemical sunscreen that the EU decided could potentially be an endocrine disruptor, but it's not on his list because it's only allowed in the EU and Australia. It is 4-MBC. But it's being removed completely not because they actually think it's dangerous, but because there wasn't enough data to work out what the new limit should be. So this is a super precautionary change. The assessment was done in April 2022, but you can still sell products with it until May 2026 in the EU. So it's not like they're knocking these out of people's hands. It is a really, really high bar for safety. That is the only sunscreen ingredient that I would personally try to avoid in body sunscreens if I was pregnant. Otherwise, I really don't think it's a huge issue. Also, safety assessments do take pregnancy into account. The safe limit is often based on a tiny effect in animal fetuses. So for oxybenzone, the change that set the new safe limit was less sperm-producing cells in male rat fetuses. Again, everything is just super precautionary. I think reading these safety assessments is actually really reassuring about how safe our products are. It is true that no one can say with 100% certainty what the effects over many years are, but science generally doesn't do certainty. Scientists won't even say things like the sun will come up tomorrow because we don't actually know that. But we also have to think about the alternative scenario if you didn't use chemical sunscreen. We also aren't sure that mineral sunscreens are 100% safe or that repeated sun exposure without sunscreen is 100% safe. And in fact, that is almost all the time more dangerous. I don't really want to harp on about safety issues with mineral sunscreens because I feel like they aren't really that concerning, same with chemical sunscreens, but I will a little bit just to even out the playing field a bit. Titanium dioxide was banned in food in the EU as a potential cancer risk. It's a controversial decision, but I think it is worth bringing up if we're bringing up things that aren't super concerning. For cosmetics, the nano form of titanium dioxide has been banned in products that might be inhaled, even though chemical sunscreens are still considered safe for those. Mineral sunscreens could also potentially be linked to hair loss around the hairline. There's not a lot of research on that, but there is a bit of preliminary data. There was also this big thing about how they are photocatalytic. That means that they are stable, but when the UV comes in and hits them, they react with things around them, like other things in the sunscreen and also things in your skin. Free radical formation gets brought up a lot with chemical sunscreens, but it's probably a bigger issue with mineral sunscreens, especially titanium dioxide. With both of them, it's probably not a huge issue because it is on the very top dead layers of your skin, and it is preventing further free radical formation lower. A lot of mineral sunscreens also contain SPF boosters, which are modified versions of chemical sunscreens, but because they don't count as chemical sunscreens, they are less strictly regulated, so comparatively, they are less safe. There are actually 2 of these in the sunscreen he recommends. Again, I do not think these are huge issues. The best sunscreen is the one that you like enough to use a lot of and often. But it's really frustrating when dermatologists spread these myths on social media that makes people think that they have to use mineral sunscreen. Most people don't like the feel of mineral sunscreens as much, and they give a white cast. So if people are being misled into thinking that they are the safe option by medical professionals, they're going to apply less or even skip sunscreen altogether. And as someone who has been dealing with misinformation about sunscreen online for years, misinformation from dermatologists is particularly sticky because people assume dermatologists are experts on everything skincare, but this isn't the case like we saw here. Dermatologists are medical doctors, their specialty is medical skin conditions and treatment. Standard dermatology training doesn't really cover much on regular cosmetic skincare or formulation, even when it comes to things like topical drugs. I recently saw a dermatologist saying that indoor lights will deactivate tretinoin, and no, it doesn't. So before you trust what someone is saying, think about who the most relevant experts are for that topic and check whether they say the same thing. This graphic that my friend Jen of the EcoWell made for Beauty Psychon might help you. And if you could be perceived as an expert, I don't think experts necessarily need to stay in their lane when it comes to making content, but it is responsible to check what the relevant experts say on that topic before making the content and pushing it with authority bias.
Stop wearing sunscreen because it's terrible for your skin. Let me tell you why. Okay, so if you're wearing sunscreen, it is supposed to, help you prevent, sun damage, all that good stuff. You know what's actually doing when you wear sunscreen? It's messing up your estrogen levels, it's messing with your hormones, it has a lot of bad toxic things inside of it, and it is damaging your skin. I noticed this when I started wearing sunscreen a lot in the summer, and my chest started breaking out. Places I usually didn't have acne were breaking out. And instead, now I use 100% like zinc oxide mineral sunscreen.
If you're breaking out from sunscreens, it's not because it's disrupting your hormones. I talked about that before. But yes, sunscreens breaking people out is a big problem. It's one of the big reasons people stop using sunscreen. I'm pretty acne prone and I've tried hundreds of sunscreens. It is a massive pain when they break me out and then I have to film a video and then I get a whole bunch of comments saying, how can I trust what you say about skincare if your skin is bad? And it is really annoying, so I can relate to how frustrating this is. But for most people, it isn't the chemical sunscreen ingredients, it is the other ingredients breaking them out and the overall formula. Whether different products and ingredients interact with your skin to cause clogged pores depends on so many factors, like the proportions of stuff in your skin oil, which will be different for different people depending on genetics and diet, your pore lining, what sorts of microbes are on your skin. For me personally, it's actually usually mineral sunscreens that break me out more, and that is the case for a lot of people. And there are heaps of exceptions as well. There are some mineral sunscreens that don't break me out. And my theory is that it's mostly the thick, heavy base that a lot of them use to keep the mineral particles suspended that's causing that problem. But I found tons of sunscreens that don't break me out. She's obviously found one too. So yeah, anyway, there probably is a sunscreen out there that won't break you out. But if you only stick to mineral sunscreens, that is probably not going to be a very efficient approach.
I remember hearing years ago, oh, there's stuff in sunscreen that will go into your brain. I remember someone telling me that, like, you're crazy. What are you talking about? I'm a scientist. Turns out there are certain sunscreens that have molecules that can cross the blood-brain barrier. You can find them in neurons like 10 years after people have used this sunscreen topically. So I've become not paranoid about this. I don't tend to use sunscreen.
Okay, this is a wild claim. I'm going to put the transcript up here because a lot of people said I was taking him out of context, so here's the context. I think that a reasonable man on the Clapham omnibus would agree that he's saying scientists have found sunscreen molecules in people's, like human people's brains 10 years after they stopped using the sunscreen. He seems to think the specific ingredient is triclosan, but he's not really sure. I'm pretty sure this is not it. Triclosan is not in sunscreens. It was banned in the US in 2016 because of antibiotic resistance. So avoiding sunscreens because of triclosan would be like avoiding refrigerators because you don't like dial-up internet. It's not around anymore and it was never in that thing in the first place. He said in other places that he doesn't like chemical sunscreens, so I'm going to assume that whatever he heard was about chemical sunscreens because that's what stuck for him. So before this video popped up on my feed, I honestly had no real opinion about Huberman. I knew he had a podcast, he was a professor at some good uni, I assumed his podcast was probably reasonably accurate. But sunscreen is my specialty area, so when I heard this claim, it was just immediately sus. I've been debunking sunscreen myths for like 8 years. I've read so many articles and reviews and textbooks on sunscreen safety. This finding literally exists nowhere except in this clip. When I got to it, it had like 10 million views or something. I couldn't find anything in the literature that even resembled this, and we all know the EWG loves scary sunscreen stories, so if this actually existed somewhere, they would know about it, they would be pushing it. And even if there was a study claiming this, it is just an extremely dubious claim. The biggest problem here is that chemical sunscreen ingredients aren't just in sunscreens, they are in tons of other products they're used to protect other ingredients from UV, things like coloring agents and fragrances. So that means to link the sunscreen in the brain to applying sunscreen, you would have to make sure that firstly, someone completely stopped using sunscreen for 10 years. So That's reasonable enough, but you would also need to make sure they didn't use anything else that could potentially have chemical sunscreens in them. So this includes stuff like public bathroom soap, or like fragrances that you might smell in a shop, or laundry detergents. I talked to a bunch of biomedical researchers and even more issues came up, like you cannot get ethics approval to donate your brain tissue for like a sunscreen study, so they would need to be either working on people who died exactly 10 years after they stopped using sunscreen, or people who needed brain surgery exactly 10 years after they stopped using sunscreen. And public bathroom soap and all of those other things as well. And this is not like a common question on body donor surveys, so the pool of people they would have, like the pool of brain tissue they had, would have to be really, really small. Some people suggested it might be an ingredient that's been phased out more than 10 years ago, but the only one is PABA, but that is actually naturally in your body already, so again, you can't trace it to the sunscreen. I think it's possible that a few molecules of sunscreen do end up in our brains. We have tons of molecules in our bodies. We probably have a few molecules of all sorts of junk in there. I mean, we all have a whole bunch of uranium in our bodies, so like, it's not a stretch. But whether they're at a high enough concentration to be detectable 10 years after you use them topically is super questionable. And I mean, then there's the question of whether that concentration is high enough to have any sort of effect, harmful or not. And then on top of that, there's the whole tracing them back to the sunscreen. It is just like a lot of stretches going on. So I stitched this and I asked if anyone had actually tried looking for this study because I was pretty sure it didn't exist. He has a lot of fans, so unsurprisingly, I had a lot of people telling me, there are tons of studies, you're an idiot, and a lot of them didn't link anything. Now, some people did give me links, so this is a review that has studies where sunscreen ingredients were fed to rats or fish or they were put on cells, but there is nothing on human brains and nothing about 10 years. This one is a cell study, so no human brains, no 10 years, no putting it on skin. Plus, Huberman has said that it is chemical sunscreens he avoids. This is on mineral sunscreen. Someone mentioned triethanolamine, but this is even worse with the tracing problem. It is a pH adjuster that's used in way more products than just sunscreen. Some people have suggested it's some mysterious unpublished study that only Huberman knows about, and again, I just don't see how this claim could be made reliably with any study design. Anyway, this wacky claim, I guess, wouldn't be such a big problem if he wasn't so influential. This clip had millions of views by the time I got to it. If you look through the comments, there are so many people saying that they just don't use sunscreen anymore because of this. In other places, he said he's as scared of sunscreen as he is of melanoma, which is really wild. I'm Australian. I know people with melanoma. I know people who were really young who died of melanoma. I do not know anyone who has died of sunscreen. He's tweeted that he's been talking to experts and he's planning a sunscreen podcast, but I wish he did it before he started saying this sort of stuff. Again, I think it's responsible that if you are perceived as an expert, you need to really check things properly when speaking outside of your expertise and also within your expertise. After I posted about this, I got a whole bunch of messages about scientists debunking Huberman when he got stuff wrong in their field of expertise. So for example, Dr. Andrea Love has a breakdown of what he got wrong about immunology in his cold and flu episode. I will link that in the description. There are also his recent podcast episodes on cannabis and back pain that a lot of actual experts in these areas have criticized. I've seen a lot of people doing this hack, but transferring products to a different container is usually not a good idea, especially for sunscreen. The reason is sunscreen is pretty unstable and the ingredients can react with some container materials. So glass is usually okay, but plastics can react, and the sunscreen ingredients can actually soak into the plastic, which means that it is not in your sunscreen, it won't end up on your skin, you're going to get less protection. The solvents can also just start evaporating more, and that can mess up the structure of the product and make the sunscreen split, or it might go clumpy. And this happens with other products too, so common ingredients that mess things up are preservatives, active ingredients, solvents. A lot of people don't know this, but when the product is being designed, the packaging gets tested with the formula to make sure the two are compatible. I went to a sunscreen lab once and they had a whole bunch of deformed and funny colored bottles that had obviously failed this compatibility testing, but it is hard for us at home to work out whether or not this is a problem because we can't measure the active ingredient amounts. Mineral sunscreens are also a problem. This cosmetic chemist did an experiment with mineral sunscreens and you can see all of this just started clumping up. A safer hack would be to squeeze the sunscreen out on the back of your hand and then use the cushion to apply it. You would also be able to see how much you're applying because these cushions tend to not give you a ton of product.
I swear, I must love torturing myself. I was in my lab yesterday and I made a chemical SPF 50 lip balm. It's juicy, it's hydrating, it's easy to apply. I could get this manufactured in 1 month after tests and it'd be a bestseller. But you and your family would be constantly ingesting chemical SPF 50 and that'd be less than ideal.
She's a doctor and not a dermatologist this time, but it is the same sort of problem, not checking what toxicologists have said about this. This was really nicely debunked by Mo of Mo's Skin Lab. He is a toxicologist and safety assessor. He's one of the few who are really active on social media. He's great to follow on both YouTube and Instagram. So I'm just going to play his video on this.
As a toxicologist and safety assessor, what is less than ideal is insinuating that incidental ingestion of chemical UV filter from your lip SPF is something to worry about. Because when assessing the safety of a chemical UV filter for the approval process and usage in sunscreen formulation, not only we consider the dermal exposure but also inhalation exposure. And yes, you guessed it correctly, also oral exposure.
Yeah, so the thing is, cosmetic chemists look at safety assessments from toxicologists when making products. If these chemical sunscreens were not safe for use in lip products, then there would just not be so many SPF lip products on the market from big brands in like every region. I also wanted to play this clip from Mo because he talks about something that I get a lot of questions on. What happens if you use multiple products with the same ingredient in them every day? Will they add up?
And if you thought we will stop here, you would be unfortunately mistaken, because toxicologists love to make things complicated for your safety. Because we also consider something called aggregate exposure, which means we know you as a fancy consumer. You will use product, more than one actually, that may contain the same active ingredient, or in this case a UV filter, a chemical UV filter. For example, we calculate the systemic exposure dose of inhalation, as you can see first, a dermal product, which is maybe a face cream, and then you use the hand cream that contain the same UV filter, and also a lipstick that contain the same UV filter. So please, next time when someone is trying to make you afraid of something, even if they are a person of authority, ask them what is your expertise in this field, and always be critical.
This is excellent advice. Fear is really great for social media algorithms. So I posted this guide to clean beauty marketing tricks recently, and one of the big ones is appeal to emotion. If something makes you feel scared, stop before you take any action, like sharing it or throwing out your products. Fear is a really big red flag. Strong emotions actually stop you from thinking critically and engages that sort of primitive brain of ours, that emotional response. Critical thinking is the opposite of that. It is slower. It is something that we've kind of developed over time. Scary claims about common products is just a really easy way to catch people's attention online, and most of the time it just doesn't pan out because safety assessments exist.
It's summertime, and there's two types of sunscreen, chemical-based
and mineral-based.
The problem with chemical-based sunscreen is that they are absorbed by your skin, and the active ingredients like avobenzone and homosalate are endocrine hormone-disrupting ingredients, and these ingredients are actually found in the breast milk of mothers weeks later.
It is tradition to have Bobby in these videos, and who am I to break tradition? This time he's got a friend, I think his name starts with K. He has a wife who also posts like non-toxic stuff. I'm just gonna call him Bobby 2 for now because that seems to be like the brand he's going for. I already talked about absorption and endocrine disruption. Absorption, yes, it does absorb, but the amount is really tiny. The latest safety assessments haven't found enough data to say any of the active ingredients in US sunscreens are endocrine disruptors. Now, finding stuff in breast milk, that sounds really scary, and I've said before that a lot of these fear-mongering videos like to talk about babies and pregnancy. It is great for engagement because if you assume that these guys know what they're talking about, you would want to share this with your pregnant friend. Like, you care about other people, you care that they're not getting hurt. It is so predatory. There are so many like BS rules about what pregnant people can and can't do, and if you're pregnant, you just don't need more stress. So again, the risk depends on dose. The amounts detected are incredibly small because we are really good at detecting things, and the EU safety assessments do take all of the relevant data into account, including like breast milk data.
Also, other active ingredients in here are horrible for the aquatic system and the reef, which is why certain chemical-based sunscreens are banned in places like Hawaii.
This is another really annoyingly persistent myth. It's another one that was started almost entirely by one single paper, which is just disappointingly common in beauty. I debunked it in 2018 and again in my video on sustainability myths, but in short, the measurements in that original paper aren't reliable for a whole bunch of reasons. In 2022, the National Academies actually brought together a whole bunch of scientific experts, including a whole bunch of marine scientists, and they reviewed all of the data on the environmental impacts of sunscreens. There is a 400-page report that you can read, and this original study was just a huge outlier. Overall, mineral and chemical sunscreens overlap in terms of environmental impacts, and in fact, you can see that in this chart, zinc oxide is actually worse than a lot of chemical sunscreens for tons of effects. But overall, it seems like sunscreens just do not have that much of an impact on reefs, especially compared to other issues like global warming. There was just a huge bleaching event with the reefs in Australia. And again, relevant experts is important here. The review he is showing on screen here is written by dermatology academics, not environmental scientists. Kind of wish they wouldn't write about environmental issues. The National Academy's report is a much better source here. Over the years, a lot of people have also referenced this NOAA page. This was actually referenced in the National Academy's report as an example of misinformation next to the EWG. It's disappointing because you would think that the NOAA are relevant experts, but if you dig deeper, it seems like this page was just made by a librarian. They just compiled abstracts together without actually critically appraising them. This page has been updated saying that they're reviewing the National Academy's report and they'll update this page based on that, but that was like September 2022. You kind of think they should have done this by now. There's actually a whole bunch of interesting stuff about the scientists behind this 2016 study and the Hawaii ban. Two of them were actually in my Valley Shore whiteboard map, so I might do a deep dive at some point.
So what do you look for instead? Mineral-based sunscreen, specifically zinc oxide. It doesn't get absorbed by the skin and it's 100% non-toxic.
Nothing is 100% non-toxic. Like I said, there are some safety concerns for mineral sunscreens, but they are safe in the way that they're currently used, just like for chemical sunscreens. But these guys have such a double standard, and a lot of it really just comes down to the appeal to nature fallacy. Mineral sunscreens seem more natural, they have more natural names, so people assume they're safer and they pick information to support that. If you have more questions about sunscreen, check out my video where I answer almost every sunscreen question. If you have general questions, I highly recommend my book. I also have more TikTok torture in previous episodes.